So this disc-shaped fossil, which to the first geologists who noticed these fossils in the Flinders Ranges, looked like a jellyfish. It looked like some kind of medusoid, the sort of thing that you might find washed up on a beach at low tide. It's, as you see, almost perfectly circular. It's got concentric rings and then these radial lines coming out from the center. And when paleontologists looked at these 50 or 60 years ago, they were pretty sure that this was what they might expect from a jellyfish. Radial muscles and concentric muscles, which enabled it to swim through the water. The problem is you couldn't see the tentacles that you see hanging off the bottom, the feeding tentacles which have the sting cells on those soft corals, because that's really what a jellyfish is. It's a swimming and floating kind of a soft coral. It's related to the things that make corals in reefs. And we know they're very primitive creatures, but in this case we really just don't see those tentacles. What we sometimes see when we turn the specimen over, and we don't see it here, is evidence of a stalk coming out from the top of this disc. And so we now think most of these are actually holdfasts. It's the organ that this creature uses to embed itself in the soft sea floor so that it isn't immediately washed away when there are a few currents or there is a little bit of wave action. But if you get a very large storm which involves a slurry of sand coming down from very shallow water into slightly deeper water, it can actually rip those off. But the holdfast's already buried. So it preserves very readily, and that's the problem with looking at fossils. You don't always know that you've got the complete creature. So the frond-like fossils, often thought to be fossil sea pens, are very rarely preserved together with the discoidal holdfast and the stalk that attaches them to that holdfast. But we have enough specimens to know that it was probably a very common relationship.